Before we get started cutting our cabinet parts, let's take a little bit of time and talk about the table saw. If you were to talk to a cabinet maker and ask them what one stationary tool would you want to have if that's all you could have, 9 times out of 10 they would pick the table saw. It's a very versatile saw. You can do lots of things with it. You can even cut circles with it. Let's talk about it just a little bit and about what makes up a table saw. We've got a table, we have a fence, and of course we have a table saw blade. And in this case we have a 10-inch, this is a 10-inch saw. We're able to move the saw blade up and down by turning this crank. And we can also set the saw blade on an angle and cut a bevel by turning this dial over here. And we can rotate it. And I'll show you a little bit more about that in just a moment. But let me first start by installing the blade. We want to make sure that we orient the table saw blade teeth towards us. So we want it to rotate this way. So I'm going to make sure that I put it on with the teeth facing me, put it onto the arbor, and then I have a washer and a nut that I'm going to put on and tighten. One thing that's sort of unique about the table saw is that the blade, because it's turning towards us in this direction, we have to use a reverse thread on the nut. So you're actually putting it on, tightening it in the opposite direction that you would normally think of. You've all learned the saying, righty-tighty, lefty-loosey. Well, this is just the opposite. Tighten it down, hand tight. Then I'm going to put the wrench on. Bring the wrench down to the table, and then just hand tighten it. That's all you need to do. All right, now that we have the blade on, we have to do something about this large opening that we have here. And we needed this to get our hands in here and get the blade in. But now that we're ready to use the saw for cutting, we want to close this up. Now, the factory makes a throat plate that looks something like this. This is what actually came with the saw. Fits right into this opening and fits down nice and flush to the table. The only problem with this type of throat plate is that as the material runs through, there's no backing for it. So that as the blade turns down, it wants to tear out material on the back side of the cut. So what cabinet makers have come up with is the custom throat plate. And this is one that I made for the table saw. And just basically use this one as a pattern and cut it out on the table saw and on a band saw. And I got it planed to the right thickness. You can clearly see that there's no place for the material to break away. It's nice and tight here. That's going to give us a real clean cut, and that's very important when we're working with melamine particularly, because melamine is a water-based resin. It's very brittle, and if you give it a chance to chip out, if you look at it wrong, it'll chip on you. You may be wondering what this little fin is sticking up here. That's actually a splitter. And what that's going to do is it's going to keep the material as it goes through between the fence and the blade. It's going to keep it from wandering away from the fence. Let me just show you a couple of other little fine points about the throat plate. This is the factory model again. There are Allen set screws here and here, front and in the back. As you turn them, you have little posts here that sit on these shelves, and it allows you to adjust the throat plate so that it's perfectly flat to the table. The way we deal with this on the custom throat plate is by putting masking tape on it. And we just basically build masking tape up where these little tables are and get it lined up so that it's perfectly flat with the table. Nice and flat. One last point I want to make. When this throat plate came from the factory, it was nice and straight along this line and this line. And if you take a look at it now, you'll notice that there's a sawtooth cut right there. And there's some back here in the back end that you can see, and there's a couple over here. Those happened as a result of kickback. Let me show you how much force it takes to get that blade to move over that far to make the nick in the throat plate. If I push on this with all of my strength, I cannot move it over even half the distance. So you can imagine what's happening when a piece of material is running through here and all of a sudden it moves away from the fence, it jams. And the minute that happens, it's going to make a nick like that, and that piece of material is going to shoot back. And if you're standing there, it's probably going to hit you, and it's not fun. And it happens to every cabinet maker at some point in their career, and it's a life-changing experience. And I'm going to try to show you some strategies today that will help you avoid kickback. Probably one of the best things and easiest things you can do is to use a splitter on the table saw, because it keeps the material from moving away from the fence. One of the most common errors I see operators making is that as they run materials through the saw, they watch the blade, but they don't watch the relationship of the material to the fence. If you're watching the blade, you can't see the material move away from the fence as it is here. You've got to watch and make sure that your material is staying nice and tight to the fence, just like that. The blade will take care of itself. We do have a guard that we can put over the blade so that you can't watch it. Gives you a little bit more protection. Another way to avoid kickback is to orient your body and all of your weight towards the fence. So you're pushing like this. All of my weight and focus is going that way, keeping it tight to the fence. If I stand back and run the material through like this, it's very easy for it to wander away from the fence. But if I'm oriented this way and I've got my feet set and they're facing towards the fence, I can very easily keep this material tight. And you'll always get a really nice clean cut that way. All right, let's talk about some of the adjustments on the blade guard. First of all, we have a lever that we pull to lower it and raise it. When you raise it, it locks in place. You can also move it forward and backward, depending on what you're doing. And there's also, on the back end here, there's a counterweight that we can move in and out that balances this so that it's dropping without, going down with a thud. We want to adjust the counterbalance so that this guard is just sort of floating here, so that as the material runs underneath it, it can go up easily. Okay, I've shown you how to adjust the guard up and down. Let me show you how to move it back and forth. There's a lock right here, and inside this steel tube there's a threaded rod that's attached to this little crank arm here, and I can just turn it and it'll move towards me, and if I go in the opposite direction, it moves it back the other way. And once you get it adjusted so that the blade is roughly in the center, you want to make sure that you come back over here and lock it back down. Accuracy of measurements is one of the hallmarks of a good cabinet maker. And so one of the things that we focus on the table saw is our scale here. And as I pointed out before, this scale is both given in inches and in millimeters. And right here we have a little plexiglass cover with a hair on it, and that's where we're going to read our measurement. So if I wanted to set it at 9.5 inches, I would get my eyesight directly over the hair mark and set it right on 9.5 inches. Before you cut your cabinet parts, run a test piece to make sure the fence setting matches the actual cut. All right, now we're ready to start bringing our cabinet parts down to their exact size here on the table saw. These are the parts that we cut over on the panel saw. You remember the bottom, the top, and shelf, and our two sides. One point that I want to make is that we need to cut all four sides of every part with that blade. That way we'll be sure that we get a real nice clean cut. So we're going to cut a little oversize, and then we're going to flip the piece around and we're going to cut it to exact size. One thing to remember is what you do to one piece, do to all of the pieces at the same setting. Let me show you what I mean. I'm going to start with the sides. The sides are 601 in height, so I'm going to set the fence to, I'll set it at 620. Notice how my body and my vision is angled towards the fence. That's going to help prevent kickback. Remember to flip the pieces over. And remember what I said before, what you do to one piece, do to them all. Then set the fence back at 601 to the exact size that I want. With the fence set at 601, I'll run the first side through. With the setting still at 601, I'll run the second side through next. Now I'll cut the sides to depth. Remember, we cut our parts to a nominal size first. Since the finished size is 374, I'll make the nominal cut at 385. Notice that I push the material past the blade and fence each time to avoid kickback. Also notice that I flip the pieces around after each cut. Now I'll move the fence to 374 and cut the parts to their exact size. Side 1 first, followed by side 2. Now it's time to size the top and bottom. I'm going to start with the width, and because they're part of this longer board, I'm going to cut both bottom and top in one pass. The shelf piece we'll set aside and cut it later. Now I'm going to set the fence at 330, which is just about 8 millimeters over our finished cut of 322. And I'm going to make nominal cuts. First I'll cut the bottom, flip it around, and cut the top. Now I'll set the fence at 322, the exact size that we want. Because I flipped both pieces around, I don't have to wonder which is the finished cut. Now we'll cut the bottom and top to their depth. The depth is 355 millimeters, so I'll set the fence to 365. I just checked to make sure that I was cutting the board in the right direction. Notice I flipped it around, and now I'll make another nominal cut on the bottom. And now I'll size the top and bottom to their exact finished depth, which is 355 millimeters. First the top and the bottom. Okay, I just finished cutting my bottom and top to their final finished sizes. And I want to stop and just make a point here. I cut the bottom and top to width first and depth second. And that's very important, and it's going to be clearly obvious to you here very soon why I did that. But just keep that in mind. Always cut your length, the width of the cabinet first, and then the depth last. So what I'm going to do now is I'm going to mark these parts because they almost look square, and we might get confused on what's the depth and what's the width. So I'm going to mark them, first of all, bottom and top, and then I'm going to measure just to make sure the width of the bottom and top is 322 millimeters, so this is the width here. So I'm going to mark the front edge of this piece so that I know that that's the front, and I'll also do this with the top. Just double check here, yep, and we'll mark it. And while I'm at it, I'm going to check the depth to make sure it's what I want. 355 millimeters, it's right on. All right, now that we've sized the top and bottom to their exact size, it's time to cut the dado in the sides of the cabinets for the back. So let's go do that. Now a dado means that we're not cutting all the way through the thickness of the material. So this throat plate isn't going to work because of this little fin sticking up back here. So first thing I'm going to do is change this out. One subtle point here, but very important point that I want you to note is that the fence is still set exactly where it was when I cut the bottom and top to their exact depth. So there you can see it's still right where it was. This is an important point, and I'll come back to it in just a moment. But what I'm going to do now is I'm going to crank the blade down so that it's 10 millimeters above the table, because the depth of our dado is supposed to be 10 millimeters. So I'm going to crank this down to, about what I think is 10 millimeters. Now I'll run a test piece to see if it actually is 10 millimeters. Notice that I used a rather narrow piece for my test, and that's okay in this situation because I'm not running it all the way through. I'm just running the piece to the high point of the blade and switching the machine off with my leg. I'm right on 10 millimeters. Okay, now that we've tested our dado to make sure that it's the proper width so that our back fits nice and snug but still slides freely in the dado, let's go ahead and cut dados in our sides. With the blade height set at 10 millimeters and the fence already set to the depth of the top and bottom, we're ready to make our first dado pass on our sides. First, side 1, and then side 2. All right, I've made the first cut for the dado in our sides to accept the cabinet back, and I just wanted to take a moment and talk to you about why we left the fence where it was when we cut the bottom and top to their depth. By leaving the fence in that position, I was able to cut the dado and the bottom and top to exactly the same depth. Even if you're off a millimeter, they're exactly the same, and that's what really matters. Being off a millimeter on the placement of a back really doesn't matter. So I just wanted to show you that, and now what we need to do is to widen this cut by making another pass with the table saw so that the back will fit in here. The blade kerf on the saw is only about 1/8 of an inch wide, and the back is about 1/4 of an inch wide, so we need to make this a bit wider. What I did was I cut at the same setting. The fence is set exactly where it was when we cut these parts. I took a piece of scrap material and made a similar cut, and you can see it lines up exactly the same. What I'm going to do is just move the fence over to the right and make the kerf a little wider, and then I'm going to test it and see if this piece fits in there. I'm not going to take any measurements. I'm just going to keep testing it until it fits. We want to have it so that it's snug, but we also want to have it so that you can slide it in easily. You don't want to have to pound it in there. So it's really useless to take measurements. You just want to feel it, see how it feels. The most common mistake I see made is when this second cut is made, the fence will get moved towards the blade, which is not what you want to do. Remember, we made the cut just like this. You can see that if I move the fence this way, I'm going to be cutting into the cabinet. I want to move it to the outside. All right, so I'll take the first stab at widening the dado. And it looks like I've widened it a little too much, and indeed that is the case. So now I'm going to move the fence a little bit to the left and tighten it up a bit. I'll run it through again, and notice that each time I only run the piece in about 1.5 inches. And this time it's a little too tight. So now I need to move the fence to the right. If you run the dado through all the way and you're too wide, then you can't test it again. So that's why I only run it about 1.5 inches or 2 inches. And there it is, a perfect fit. Now I've run the dado all the way through my practice piece, and I just wanted to show you that it fits in there nice and snug, and yet it's easy to move so that we won't have any problems sliding it in after the cabinet is built. One final thing, when you finish with the table saw, there's a couple of things that you still need to do. One is to reinsert the splitter if it's not already in. And finally, crank the blade down so that it's below the table level. For the time being, we're finished on the table saw. Let's move over to the router table.